I'm going to talk about this. Okay, I, I was really hoping he would talk longer. I'm completely unprepared. Never done this before. Um, I'm sorry. I can't help myself sometimes. All right, so Consexpr. This is a scripting engine that I've been working on for a little while. Is that too small? All right. I tried to embiggen it all before I got up here. And I didn't plug my laptop in for power, so hopefully the battery doesn't die. Okay, so just for the record, the name Consexpr, this I believe was JF who ultimately ended up suggesting this on Twitter, JF Ashton. It's like Constexpr, but the T is missing. But it's a scheme-based language, so it's also cons expressions. Get it? It's like all the things. All right. So this is my new C++ embedded scripting engine. For those of you who do watch the YouTube channel, I did cover it briefly on here, but I thought it made sense to put together some of my thoughts. So as you can see, I just have a giant markdown file. I didn't do slides today, but it's not the first time I've done this for the meetup. So I wanted to make a new scripting engine that righted the wrongs of ChyScript. Just out of curiosity, who's heard of ChyScript? Way more people than I expected. Okay, so I started ChyScript with my cousin Sophia in 2009, so 14 years ago. It was meant to be a trivially easy to use, header only, pop it in, like no questions asked, it just works scripting engine. And it did just work. You've used it, right?
Yeah, I use it.
You used it, but you don't today, right?
Sorry?
You do currently use? No, you don't use it anymore. Okay. Every now and then I'll have some random person come up to me at like a conference and be like, I just used ChyScript. I was wondering if you still maintain it. I haven't maintained ChyScript in like 3 years because I got really frustrated with compiler support for C++ 17. I was like into 2019 and I'm trying to upgrade it to C++ 17. Compilers aren't supporting it. I got frustrated. I stopped supporting the scripting engine because of that. But anyhow, it was this header-only thing. I started it with C++ 03, which meant it used BoostPP. Anyone familiar with BoostPP? Okay. BoostPP is the Boost preprocessor library. I'm not going to show any example code, but it was a way of creating variadic templates by using the preprocessor to automatically generate many templates for you. So with what Ali did with the ... was way harder than that. But we migrated it to C++ 11, 14, and 17. It worked with, this is good enough back there in the back? Yeah. Okay. Worked with any type provided by a user. So we used Boost Any originally, and then I ended up having my own any type, and then we got Std Any, but anyhow. So it can hold any kind of value provided by the user inside the scripting engine. But all objects require dynamic allocation. So any has a small object optimization. If I put an int in any, it's good. If I put my really fat object that's bigger than its built-in storage, then it does a dynamic allocation and it stores that thing on the heap. But aside from whatever dynamic allocation the any-like thing might do, I had every single object in ChyScript stored as a shared pointer. So even if you had an int, it was a shared pointer to an int. That sounds like highly efficient code, right? Yes. Okay. The poor decisions were made. Part of the reason is we didn't have unique pointer. Part of the reason was I didn't know what I was doing. It was a long time ago. Mistakes were made. I, in some cases in ChyScript, use exceptions for flow control. Yeah. So if you return from a script function, it actually throws a return exception and catches it later inside the script engine. I did that for stack unwinding, so I didn't have to write my own stack unwinding code inside the script stuff. I would let it pop back out to wherever the level of the function that was expecting the return value, and then let the compiler unroll the script stack internally. Does that sound like a good idea? So, It worked. Just for the record, it does work. It worked, right, Orhun? Like, it's an easy-to-use scripting engine. It just works. It really just works. I will have examples in a second here. Getting started is basically one line of code for ChaiScript. Done. And ChaiScript syntax is close enough to C++ that you could use it as a prototyping language. And in fact, we can have auto as placeholder function types long before C++20 allowed that. So you could take ChaiScript today, copy and paste it into your compiler, and then have compiled code instead of script code. So it had lots of good things going there. And we had implicit conversions in the language, just like C++ does. We tried to stay really close to C++. Bless you. All right, consexpr is also header only. It is single header. ChaiScript was many headers. Designed today for C++23. I can't work with any type. You must specify when you instantiate a script engine exactly which types you want to work with. So those are template parameters now. I have no dynamic allocations ever in any way in the scripting engine. No exceptions ever. I just did an audit of this code to make sure that there's nothing that might even possibly throw an exception in it. Interestingly, though, if I actually correctly mark all of the functions as no except, Clang bloats my binary size, so I can't actually make all the functions no except. Yeah, Ben? Are you using Clang tidy checks to make sure you're not using like array.at? Am I using Clang tidy checks to make sure I'm not using array.at? No. What I am doing at the moment is browsing the disassembly from Compiler Explorer and looking for code that's throwing exceptions, that might throw exceptions. 100% consexpr friendly. The script engine itself is trivially copyable, so it's required. I actually have a constraint that says that the scripting engine must be trivially copyable. So at any moment, you can save and restore the state of your current script. And it's literally a memcopy. Consexpr friendliness means that my initial state can be set up at compile time, then copied for use at runtime. I have an example of that in just a second. It mostly just works. It needs some hand-holding. It's funny because my test cases have like 10 lines of boilerplate, and I'm sitting here like, what time is it? 5 hours ago, working on these notes, and I'm like, man, this example's way too long. So I just added a quick helper function. It's not committed or nothing, but it makes the example way simpler. All right. Scheme-like, but with C++ type conventions. So it's not everything that you would expect from Scheme. If I do a divide, I'm not getting like a rational number back. I'm getting a floating point type back or whatever. Zero implicit conversions under any circumstance. Who has seen all of my rants about implicit conversions? All right. You don't have to raise your hand. It's fine. I hate implicit conversions. My scripting language today will not allow them. So what ChaiScript had and what it allowed meant, and I get these, how late should I talk to? It's 7:15. Tell me when I should stop. It's 7:15, yeah. Another half hour. All right, we'll see where we get. I could probably do this for an hour. Okay, so what happens all the time and continues to happen to this day is someone will contact me and they say, I like ChaiScript, but it's slow. And you should make it faster, basically. And they always say, I should make it faster by compiling to bytecode. And I'm like, that is not where the slowdown is in the language. Yes, Ben? Are you disallowing the write and base convention? Am I disallowing? Yes, there's no implicit conversions at all. L values to R values. L values and R values do not exist in my scripting language. Okay. So yes, everything, there is no such thing as a reference. Everything is always a copy. Everything is immutable. There is no implicit conversions. It is as pure as I could possibly get in those regards. There's no references. No,
an L value to R value. Being tricky with the other.
Oh, an L value to R. It's really
That's a fundamental thing in a program.
yeah, but the concept really doesn't make sense in the system. Because if it's anything that needs to exist for longer than a function parameter call, then it gets saved in the engine state, and it just exists as an object in state. All right, so you really, okay, so people tell me, compile ChyScript to bytecode, and therefore it'll be faster. Duh, why haven't you done that yet, Jason? I've gotten this comment dozens of times over a dozen years. The slowdown in ChyScript comes in the fact that it allows function overloads with implicit conversions. So if you try to call a function inside my scripting engine, I have to say, what is the set of possible functions that this might be callable with? Then I have to order the overload set based on which function requires the fewest implicit conversions to be invocable with the function parameter set that was passed to it, and then try to call it, because I also have function guards that might prevent a function at runtime from being called. So you can say, this function is only callable if parameter x is less than 2. So then I have to do that, and then if that doesn't work, then I have to try the next function with the next set of implicit conversions with the next set of function guards. That's the slowdown. I'd have to completely rewrite the language to get rid of that. It wouldn't be the same programming language anymore. Anyhow, so my new scripting language doesn't do any of that. So this is where I say, perhaps I've gone slightly too far. No, there's no line numbers here. So all contained types, anything that might exist in the scripting language must be trivially destructible and trivially copyable. Who doesn't know what that means? No, I'm just kidding. See, no one raised their hand. No. For trivially destructible, and I've given this talk a few times, that means literally nothing happens when the object is destroyed. There's no cleanup except for popping the values, except basically changing the current stack pointer. And for trivially copyable, that means the object state can be mem-copied to one location and then mem-copied back to the original location, and it would still represent the same object. Yes?
So does trivially destructible include defaulting the destructor and defining an empty destructor?
No. If you define an empty destructor, the type is not trivially destructible. If you explicitly default it and the implicitly defaulted destructor would have been trivial, then it is still trivial, but you've still broken your move operations by mentioning the destructor. I think I got that right.
I think so. Thank you.
So it's no longer trivially copyable if you explicitly default the destructor. Yeah, I think that's right. Okay, so the unique capabilities of my new scripting language. Evaluating script at compile time. That's poorly worded. You can evaluate script at compile time and save those results in the script engine for use at runtime. That includes creating closures, other optimized script doodads at compile time, then using that work at runtime. Trivially easy to save and restore engine state, can work on any environment, no exceptions, no dynamic allocations. It is on my to-do list to prove this by running it on an AVR, like a, yeah, okay. What's the word I'm looking for? An Arduino. But it should be able, well, actually, don't tell anyone, but my real to-do list item is to get it running on a Commodore 64. Right.
Really branching out.
Look. Commodore 64 has so much less usable RAM than an Arduino AVR does. That's the point. But I don't know, isn't AT tiny? How much RAM does an AT tiny have? They're small.
The one that lived the demo one was like 1,000 bytes of program memory.
Yeah, 1,000 bytes of program memory. I might be able to work in that. No, not a per. Oh, okay, yeah, no, I couldn't do that. I could not work in that. Okay, so can work in any environment. How do we like that? It can work, well, Uni requires C++ 98, so it can't work on your environment, but otherwise it could. Okay, because it's all constexpr, I have a bunch of constexpr tests. If the tests compile, then I know that it runs that script without UB, because you can't execute undefined behavior at compile time in constexpr context. For some definition of no, because compiler conformance with this particular requirement is incomplete. Let's see. So right now it's currently less than 1,500 lines of code in its entirety. That includes comments. It is a single header. Are you all sitting here going, stupid header-only compile time templated libraries? I bet it takes forever to compile. Is that what you were just saying? I didn't even hear you, but can't believe these people with all their templates and constexpr nonsense slowing down my builds. I need my water. I forgot to get it. Excuse me. All right. We'll get to that in a second. Your character type, your integral types, and your floating point types are fully configurable. So if you say hypothetically, you want to work with int16 and float16 on your AVR, you can. Or if you want to work with car32t for who knows whatever reason, I don't care. I will handle script that is written in any character type as well. It's not to say that I parse Unicode correctly. I don't care about Unicode. I look for the sequence of bytes, and I go off of that. Okay, so. Yeah, no. What?
If there's no dynamic allocations.
No dynamic allocations.
This is not a scripting engine for, I build the scripting engine and then I have a file on the file system and I load it later.
Sure, why not?
How do you load the?
You have to pre-allocate how much memory you want the scripting engine to be allowed to use. You have to decide that at compile time. So there's I need to clean up the template parameters that you pass it, but it goes something like character type, integral type, floating point type, then number of script objects, and string table size, I believe, are the next two parameters. So anytime you put any kind of string in there, it's going to have to store it in its local string table, and then it creates its own set of offsets to that string. So you can specify how big you want that to be, and then the max object storage that it can have. So I say number of objects because each object in the system is a variant of the allowable types. So if you don't add any of your own types, those allowable types are your integral type, your floating point type, the built-in error type, lists of those things, and bool. Yeah, I think that's right. Because I just realized like yesterday that I don't think my car type is one of the allowable object types. I only allow strings. I don't allow cars. And I might need to fix that at some point. Because currently there's, I mean, like, I feel like the historical thing in my head is, oh, Lisp family languages are great at parsing. Well, but I can't work with cars, so I can't even parse if I wanted to right now. So yes, you have to predetermine at compile time the size of the thing. So if you said, I want something that can potentially be very large, then you're going to have to choose to allocate the entire scripting engine on the heap. But if you don't want to do that, then it can all live on the stack like it does in all of my examples.
And you could also write a REPL if you wanted.
Write a what, sorry?
Write a REPL?
I have a REPL.
Okay.
I even have a REPL. Oh, I have a REPL and I have like a little TUI that shows you the current state of the internal object storage and the string table, and you can scroll through all the things. I could try to launch that maybe. It's neato. Okay, so, but I was more focused on the use of what it looks like from C++. Just, come on, you can fit on the one screen. I know you can do it. No, stop it. It's trying to like snap or something. Okay, there we go. That's a complete example. I have a user-defined function called doMath. It takes 3 integers. I did that for the simplicity here. I have this const-eval function. Note const-eval. That's important. It's important to me. I'm creating this constexpr object. I'm just using all the default template parameters, which is int, double, char, and some nominal object storage size that works out well enough. And then I'm saying evaluator.add. Now note this is a template parameter. Everything that is in the system has to be trivially copyable. That includes its callables. So that means I cannot just generically add a lambda to this thing. A captureless lambda, yes. Ooh, I should have tried that. I could have done the decal type of a lambda instead of declaring the function. I'm getting some nods. People want me. Okay, but this isn't compiled code, right? This is just inside my Markdown file. And then I'm calling it doMath, and I return this evaluator. So I made this thing const-eval. So down here, I really wish I had line numbers right now. And when I call auto evaluator equals make evaluator, I know that this object is going to be created at compile time and then memcopied onto the stack at runtime. Zero, literally zero runtime initialization cost for my script engine. Guaranteed in this case. Memcopy is all it is. Oh, and then I just call evaluate to int, and I execute doMath with the parameters 2, 3, and 4. Yeah? Okay, so I wanted to compare this to ChyScript. First of all, I have in my, as ChyScript's unique capabilities is that it is actually mature and tested compared to my new scripting engine. And it is incredibly easy to use. But to be fair, I think I got pretty close with constexpr because this was like the killer feature of ChyScript, okay? This is a complete ChyScript example as well. I declare the function, I add it to the scripting engine, and I call it asking for the return value to be an int. It's neat. I like it. I'm assuming, Orhun, this is what caught your attention initially.
Basically, I use it as a file format of my data.
Yes, file format. Yes, that's
3D file format that describes the scene.
for the people, remote people, his 3D file format that described the scene, which was one of my initial use cases. Just a second, Ben. One of my initial use cases was having just come out of an environment where we had written our own custom UI like format that specified where all the widgets were supposed to be in our toolkit. And we did lots of things that were like offsets of previous widgets, but we had no way of referring to the previous widgets. And I thought, well, with ChyScript, you could declare widget locations and then just say, you know, button.x plus 3 or something like that. And that's, yeah, that's how you used it as well. It's a great use case for a scripting engine for an input file format. Yes, Ben?
S expressions are just like JSON, right?
What do you mean? So a constexpr user-defined literal for constexpr.
Yeah.
I could do that, yes.
Take an expression that's
Yeah. Yes. I mean, that's what all of my unit tests look like, basically. Yes, I definitely could do that at compile time. Yeah.
Would it count as an interpreter or would it be smaller than that?
Would it count as an interpreter? I think it counts as an interpreter.
So like would Apple catch it if you put it in an iOS?
Would Apple catch it if you put it in an iOS app? I don't think it would, because I'm not doing any dynamic compilation or anything that would trigger those tests, I don't think. I'm not ever marking blocks of data as executable. I'm not doing anything like that. This would be closer to like a, actually, I don't know what this would be closer to. What's that?
Reading a JSON file and
Yeah, reading a JSON file, basically, and then looping over the data in it, whatever. It's from the perspective of something evaluating this code, it's not much different than that.
Yeah.
Although, except I guess I do have a function pointer table that gets created at compile time so that it knows which functions to call at runtime.
It's just a data structure.
It's just a data structure that's, it's literally just a function pointer table, yeah. How do I execute closures that are defined at runtime? Well, I'll show you an example of what closures defined at runtime look like. All right, well, that's the end of this markdown file that I wrote this afternoon. So I messaged Ali, and we were making, just touching base on the fact that he is speaking today, and I'm like, I should probably get started on my talk. He seems slightly disturbed by this. Okay, so this, by the way, is Compiler Explorer. Who's heard of Compiler Explorer? I know, right? What's Compiler Explorer? Sorry. Okay, just in case you haven't heard of it, that's just a little bit of a joke because literally literally 99.9% of my YouTube videos use Compiler Explorer, plus lots of conference talks these days use Compiler Explorer. I have in here, see note on line 1, I'm including my consexpr header, which is mapped to the one that I'm actually currently editing in CLion as well. So if I change it in CLion and come back here and reload this page, I'll also see the changes there. I do have O0 at the moment. And I can just point out, for the sake of full disclosure, that this example compiled in 9 seconds, 9.32 seconds. I know you can't read that, but there's a little compile time thingy that happens here, which is it's more than twice as slow as actually running the compilation directly with GCC. So it takes a couple of seconds to compile this. But I have my make evaluator, do math. This is the copy and pasted example that we were just looking at. I've got some static asserts so that we can show that this thing can be executed at compile time. So the static assert on line 24 says require that +3, 4 can evaluate to 7 at compile time as an integer. So the fact that this compiles means that it works. And then I have just a few examples where I output some stuff, and I'm proving that I can call my do math function here. So I can. Where did you? Yes, Ben.
The built-in operators there are variadic.
They are. Writing your own variadic that you want to expose is considerably more difficult, yes. You didn't have to ask the question. Yes. It's not hard, but you have to take my special internal type that is effectively a span over the arguments that you were passed, and then operate on them individually. As you know, there's no way to take a pointer to a variadic function. That's not possible. I'm sorry, did you say a funcle?
This function, this scheme function, funcle.
Oh. Yeah, that does. I'm sorry, go ahead. There's someone else who speaks Ben language sitting here.
Is that the one that funcle's the one that applies function to a Oh, you only makes you do it. All right. There are still a few.
So that's, yay, it does things. Okay. I have a bunch of randomness open right now. This is my game engine that I've been working on for, let's just say for argument's sake, 30 years. Let's just go with 30 years. I mean, it's been written in every language from Quick Basic to C++23, okay? It's just an ongoing thing that I do. But I've got my constevel make engine, and I'm adding all of the things to the engine that I might want to do. Now, to indirectly answer Ben's question, there are several things in here where I'm having to kind of I'm explicitly taking an S expression instead of a normal C++ type here. So the result, in this case, a callable, and then oh, I can get a lambda back, a C++ function created for me, just for the record. So you can go bidirectionally. You can add functions, and you can get functions back out of the script engine. I should show a better example of that. Can I make it build itself? How do you mean?
If you can return lambda from the scripting engine, can you compile a function into the machine state and then
Oh,
access the machine state?
yeah. Let's jump over to CLion. Stop. No, don't. What? Oh. No. Oh, stop it. Please don't ask again. Oh, no. Why is Alteryx injecting itself? Fine, I'm going to accept it for now. Son of a... Okay, well, these are all of my compile time. Well, it's a bunch of lambda, it's a bunch of things. Let's see, I'm sorry, I'm looking for... Okay, so basic callable usage. This is the make callable. So this is where I can have the engine return back a function to me. So I can make a callable that calls the internal plus operator, takes 3 integers, and now I have this thing called func, and I have to pass in the engine as its first parameter. So I ask for something that takes 3 parameters. It gives me back something that takes 4 because it needs the current engine to be able to call it on. But yes, I did use ChatGPT to, I'm writing a script engine that's scheme-based, write some tests for me. And I rolled them in, did some things. Wait, hold on. Where's that? I have the basic callable usage. Where's the not basic callable usage? It's almost as if I wasn't prepared for this. Why is it not partially applied? Because I decided that was dangerous and I didn't want to do it because I've dealt with too many lifetime issues in building ChiScript. That monitor is actually on, apparently, audio-wise. I just heard it. But whatever, it's fine. So what I do is I return the one that gives you that expects the first parameter, and then just as a proof of concept, I actually have a bind front version here. So I actually, this example, actually, here we go. This thing calls make scripted function. It creates, just like you were asking, creates a function that is a written in scheme at compile time, parses it and creates the function at compile time inside the script engine, and then returns back a lambda that was created with my make callable, and then binds a copy of the evaluator into the lambda. So now I have this thing on line 38. Func is a fully self-contained script evaluator thingy. So it's definitely a thing to do. I don't know if it's a good thing to do, but it's definitely a thing to do. Uh-oh. Not so much. It seems to be like you pay like a baseline price, and then like my test suite doesn't take, which has a lot of execution that it's doing, of tiny scripts that it's executing, doesn't take considerably longer than just that one standalone example that I showed. Yeah, Ben.
How many special forms do you have, and how do you handle environments?
Goes, how many special forms do I have and do I handle environments? I have no idea what those words mean.
A special form is like a built-in thing, so like define.
Oh, yes, those.
How many of those?
Define lambda if, no, I don't have,
Evaluate the switch.
well, they're pretty much all here. Let's see. Okay, so, all right, let's, okay, fine. I will show the code. This is the, I already accepted your stupid thing. Rainbowify is disabled for this file because it's greater than 1,000 lines. See, 1,479. I said it was less than 1,500. So I have these. These are the built-ins. Then my special forms are if, for each, list, lambda, do, define, let, car, cutter, cons, append, eval, and apply. Some of those could be implemented. Some of them could be implemented in Scheme, but most of them cannot be. I mean, in my version of Scheme, they could not be directly implemented. Some of these, I think, no, maybe not. I was going to say like maybe append wouldn't need a special form, but maybe it does. I'm not sure. Yeah.
Well, scheme only depends if it has 5.
Okay. Ben says Scheme has 5. Look, this is my some knowledge of Scheme, okay? The background on this partially is that the project that I had to write in Scheme for my comparative languages programming class in my junior year at university, I failed. I never got the program to work. So 25 years later, this is my revenge. I have made compile time Scheme in C++ 23.
Look up the professor. Just email them a link to your dinner. With no other comment.
Look up the professor. Who is that?
Whoever created it.
Oh, I thought you were referring to like another YouTuber or something. The professor. No, look up the professor. No, no, he was actually a really nice guy. Although my cousin and I were in that class together, and we often distracted the professor. It was fun. It was fun from our perspective. I think some of the other students hated us. And then we always went to Savlaki's for Greek lunch immediately after that class. It's a good day. It's a good year. The Tuesday, Thursday class. I don't know why I remember that. Yes.
How do you, when I write lambda,
Yeah.
closure,
Yeah.
what do you do?
Okay. So what do I do internally when you write lambda with a closure? How do I do that? Okay. So I will explain it instead of showing the code. I take all of the things that I look through all of the identifiers that are used inside the lambda and say, do any of those identifiers exist in the current scope? If they do, then I do a transformation of the lambda doing a replacement of all of those values. So I effectively compile the lambda with a partial application of whatever function, whatever parameters can be. But then the ones that aren't, the actual lambda parameters, of course, those identifiers stay how they are. But then if I were to make another lambda over that lambda, then I am going to then deeply do a replacement of all those values. So lambdas are actually, in some ways, more efficient than other function calls-ish, because they can do this. But that's what I meant before when I said everything is immutable and there's no such thing as a reference. Because in real Scheme, if I used a global inside my lambda and then changed the value of that global and call the lambda again, I'm going to get a different result. That's not true in my language. Everything is a copy. There's never there's no references. Everything's immutable.
Only lexical scope.
Well, no, I can still use global scoping, but once that global scope is captured, it is permanent inside the state of that closure. So I do have, I have no idea if you all are like, why are we even looking at this? But this is some of the script for my game engine. Like if I have a 2D teleporter and a 3D teleport, oh, my game engine has 2D and 3D modes because I'm doing things with my time right now. So I mean, it does the things that you would expect to happen in a language like Scheme. I'm returning a lambda that binds a value that returns a lambda that becomes this lambda that I can then use later when I say, I want to create a new 2D teleporter that takes me to the Tencent exit in the main map. And so this is just returning a new function, right? And then that function gets saved with the set action, which was registered in the system state, which then uses that get make callable to give me a C++ function, which gets then folded back into the C++ engine. It's lambdas all the way down. Yeah, go ahead, Ollie.
So if I'm understanding this correctly, your lambdas can only take one argument and you're just doing carrying all over?
No. I'm not purist like that. My lambdas can take however many arguments they want to. I know, see, yeah, this lambda takes 2, location and direction. Because when you pop in or out of the 3D map, I need to know which way you're facing in radians. So I have predefined radians up here. And then, so this function right here this is a function called 3D teleporter defined up there. It takes 3 parameters and returns a new function that has those 3 parameters bound in, which then gets set as a location action inside the game engine.
So it's like Python with the typing, right? No types, just variable name, and you pass it to the function.
No, yes, no. In Scheme-like languages, you never specify the types of parameters, right? Am I right? I think I'm right. Pretty sure I'm right. I'm looking at the 2 people who seem to know something about functional programming. Okay. Yeah, it's always dynamically typed, but the type is fixed or something.
Yeah, you can declaim types.
Declaim types?
Okay, there you go. Thank you.
That's all sounds west.
Yes.
If you were to write that without magic numbers, would it come out pretty well?
It would be a runtime error that the identifier could not be found. Well, because this script is loaded at runtime. This script is loaded at runtime. So it would be a runtime error from the C++ world, which I would get back an error object, which is I use std expected, and I get back an error object that says which S expression caused the error and what kind of error was it. And then you can inspect that S expression. And well, let me see if I can actually pull up a thing. And then yeah, you guys let me talk way too long. Fez? Not at all. Not even kind of like Fez. I don't know which. No, not that one. Yeah, no, that one. No. I don't even know if I have a valid build anywhere in here. I might have to just make one. Do I what?
What thing is that you have? You have T, right?
Do I have
Yeah.
T. Oh yes, I have yes, but it's C++ Boolean. I don't allow T and F or hash T and hash def. I do true false to keep it more consistent with C++ types.
Are empty lists false?
Are empty lists false? I don't. No. Only Booleans are true and false. No implicit conversions.
But that's not a conversion. The definition.
No. It's in my world that counts as an implicit conversion. Only Booleans are true and false. Okay, so this is my runtime script thingy. So you can see on the left is the string table. This is every single character. If you kind of look, you can see do, no, and, or, if not, all right? So up on the top is the global objects that exist. So there's an object called plus that is a function pointer, and that is its actual memory address because it's a C++ function. I have my current use sizes. So the entire script engine is 19K, that's bytes. I'm allowing, no, let's see. Symbols used 20, this is an old version. That's a little out of date. But I'm using 74 characters. I've got 26 symbols in the global table used. And I don't even remember what values refers to at the moment. But I can do things like that. And I can get the result over here. And I can see that these were the new objects that had to be created during the parsing and evaluation of the script. So you can fully investigate all these things. And if I want to do something like this, then I'm going to, sorry, it doesn't auto scroll. That's the kind of error that I get. I got expected same types for the operator, but I got 2 different types. I mean, it could have some little bit of work, yeah.
You have a quote.
Yes, I can do quote.
You have symbol types.
I don't know what you mean. You're gonna have to ask me more at the Burns. Okay, it's time to wrap this up. Okay, so that's what I did. That's my way longer than a lightning talk embedded scripting language for C++. That's ConstExpert. Brian.
If you compile your game code, that's kind of
If I evaluated it, I could not evaluate all the game code at compile time because the rest of the game engine is not ConstExpert. Otherwise, I could. Yes. So it's what? Yeah.